because I know it's going that way. And I'm going to start at the origin, 0, 0. And the radius of this circle is right there. So I'm using my angle, alpha. That's my reference angle. If I was going to draw a standard circle, that's where I would put my reference angle. Because it's always the acute angle between the terminal side and the x-axis. On either side, it doesn't matter. That has to be, from 0, 0 and off it to the point. So we can find the lengths of the sides of this triangle. This side, we can count. 1, 2, 3, 4, 5. Length of that side is 5. And I can do the same thing here. What about that side? It's 3, but it's negative because it's going down. That's right. So from my reference angle, we have the opposite side. That's right across from alpha. 5 is the adjacent side. And r, which we don't know yet, but it's the hypotenuse. How can I, given what I know right here, figure out the radius? You can think back to the bell word. Oh, what do we do in the bell word today to find that hypotenuse? The Pythagorean theorem, a squared plus b squared equals c squared. That's right. So the opposite and adjacent, doesn't matter which one you call it, A or B. They'll work the same. As long as your hypotenuse is C. So that's 25 plus 9. Now if we read the directions, it does say find the exact value, which means we're not going to make them decimals. We're going to leave it. So we do have to take the square root of both sides here to get rid of squared. So r is plus or minus the square root of 34. Well, in a circle, the radii, it's plural for radius, is always positive. So I only have to worry about positive square root of 34. Now we have all 3 sides of a right triangle. That right triangle we just drew is called a reference triangle. And that's because it has the reference angle in it. It is very helpful in finding trig functions. Then we have sine of alpha, cosine, tangent. Remember, think back to SOHCAHTOA. What's the sign of alpha? Opposite over hypotenuse, so it would be?
-3 over square root of 34.
There you go. What about cosine? What else?
5 over square root.
You're fine. Yep.
Oh.
No, you're fine. 5 over the square root of 34. Awesome. Tangent. We're going to this right here. O over A. So opposite over adjacent. that would be, thank you. Now I wrote them directly across from each other. Hopefully they'll make a connection. The ones across from each other here are reciprocals. So sine and cosecant are reciprocals, so I just flip it. It would be square root of 34 over negative 3. But normally I just go ahead and put the negative with the top number. I don't think you've ever seen in a book anywhere when the negative is on the bottom of a fraction. So the negative is not really connected to either number. It's just the entire fraction is negative. But I wouldn't count it wrong if you put it on bottom. Just got to make sure there's a negative there. Because just because I flip it doesn't mean I'm changing the sign. So from cosine of alpha to secant, I flip it again. And it's square root of 34 over 5. And tangent cotangent, negative 5/3. See if you can draw the one for the next one. Okay, if I plot negative 3, negative 2, it's going to end up in the third quadrant. And I knew if I draw this triangle that goes from 0, 0 to that point, and then I turn it into a triangle so that it includes my reference angle, it's going to look like that. So there's my reference triangle. So what is the length, the length of this side? Yeah, it's 3, but I call it negative just because of the direction that I'm going. I'm going to the left on the x-axis, so that's negative. And what's the other side? I guess I say this side, plus u. Yep. Negative 2. Did you find the hypotenuse?